If you can hear me, uh, could you send me a message on WhatsApp? And then as soon as I know you can hear me okay, we can get started. Oh. Oh. Oh, fab. Okay, you can hear me. Brilliant. Welcome to the Tribology pub quiz. Yap has sent you. Hello. The rules of the quiz. So each question in the quiz will stay up for a minute 30 seconds, after which we'll move on to the next question. There is one section where this won't be true, but I'll let you know when that happens. Yap has sent around the link on it for a Google form where you can submit your answers for the quiz. I recommend you make a team. I suggest 5 or 6 people, but that's up to you. And you can submit your answers on the Google form. There's, I believe, 5 sections to the quiz. So each Google form only has a space for 5. And as we go through, just send your answer in. Yap will be marking that live, so we can hopefully have a result at the end of the quiz. If you've heard all of that, I would appreciate you sending a message so I know when to start. There is a slight lag on YouTube compared to what you guys are hearing, so just let me know when all that information has come through, and then we can crack on with this exciting quiz that Yap and I have conjured up for you. Just give me a shout when you've heard all of the initial information, and then we can get started. And hopefully all of that made sense. If you do have any questions, just give me a shout. I might put up my face. Actually, no. I think it slows down my computer like crazy, so I'm going to leave it as it is. Awesome. Cool. I've got the go-ahead to start. So welcome to the Tribology quiz. We're about to get going. The first section will be Christmas themed. Very apt, very exciting. Again, there'll be a minute 30 seconds for each question. I hope you're ready to go. You've made your team. You've got the Google Sheet open, ready to type in your answer. We're about to get started. Question 1. Santa Claus originates from the tales of Saint Nicholas, who traveled the lands in 300 AD and was admired for his kindness. But why is Santa Claus red? Santa Claus originates from the tales of Saint Nicholas, who traveled the lands in 300 AD and was admired for his kindness. But why is Santa Claus red? Why is he not blue or green? Or any other colour? Red actually happens to be my second favorite color, so I'm not complaining. So why is Santa Claus red, though? Minute to go. Less than a minute, in fact. Just type your answer in the Google form. Yeah, there is a really long lag between what I say live and what's actually being broadcast, but it should all tally up totally fine. 30 seconds. Why is Santa Claus red? Ten seconds to go before we move on to the next one. All right, off we go. Next question. Japanese cuisine is known for delightful dishes such as ramen and yakitori. But what meal is typically eaten for Christmas? Japanese cuisine is known for its delightful dishes such as ramen and yakitori. What meal is typically eaten for Christmas? I know a couple of us had Japanese food tonight. Bit of sushi. Me personally, I went for a pad thai. Was a good 8 out of 10, I think. I'm very full up now, though. Minute to go on this question. What did the Japanese eat traditionally for Christmas? What could it be? Wagyu beef. There was a Tribology conference in Japan last year. Maybe there were some early Christmas adverts and decorations up. What could they possibly eat? Is it vegetarian, non-vegetarian? Any guesses? Well, you've got 30 seconds to go to fill it out, so... What meal is typically eaten for Christmas in Japan? Ten seconds to go for this one. 5. And we're on to the next question. Question number 3. Santa has 9 reindeers. Prancer, Dasher, Dancer, Cupid, Vixen, Comet, Dunder, Blitzen and Rudolph. But how many are scientifically female? Santa has 9 reindeers. Prancer, Dasher, Dancer, Cupid, Vixen, Comet, Dunder, Blitzen and Rudolph. But how many are scientifically female? Fun fact about reindeer, their eyes change colour from brown to blue in winter to reflect more of the visible light from entering their retina. But that's not the question you need to answer. The question you need to answer are how many of Santa's reindeer are scientifically female? That's what we're looking for. Majestic reindeer in the picture here. Look at those antlers. Another fun fact, Rudolph is actually an outcome of a advertising campaign and was not originally part of Santa's reindeer posse. 40 seconds to go. Very, very sustainable form of transport, though. No friction. I mean, there must be some wind resistance between the reindeer and the air, but no research papers on that just yet. 10 seconds to go. All right, on to the next question. The world's tallest snowman came in at a record 37 meters tall. But how tall is the world's smallest snowman? The world's tallest snowman came in at a record 37 meters tall. But how tall is the world's smallest snowman? There is a picture here, an SEM picture of said snowman, and there is a scale bar, but I will say it's not the most accurate scale bar in the world. I think the snowman is actually slightly tilted, so if you were to use that image for any calculations, you will be off. There is a range on this question for the answer. I believe it is. Let me just look it up really quickly. Plus minus 0.3 microns is the range for the answer to this question. So if you're within that, you'll be getting points. This is question number 4. Only one more to go in this section, and then you'll be submitting your Google form. Very, very cheery snowman here. I'm not sure what it's actually made out of. I'm curious how they made it. How tall is the world's smallest snowman? 5 seconds to go. And we're done. Moving on. Next question. 40 to 50% of Sweden tune in on Christmas Eve to watch a cartoon featuring a classic Disney character. What is the name of this character? 40 to 50% of Sweden tune in on Christmas Eve to watch a cartoon featuring a classic Disney character. What is the name of this character? There's an image to help you out here with the immediate Disney family that comes to mind. I'm actually not sure who these little ducks are. Not a big Disney person myself. There's a Scrooge McDuck there. Is it Mickey Mouse, maybe? The Swedes' avid Mickey Mouse fans. Perhaps Goofy? Could you see Goofy being a lovable character in Sweden? Could be. But it's your job to guess, not mine. What is the name of the character that Swedes watch on Christmas Eve? Bit of a weird tradition, but to each their own. 5 seconds to go for this question. This will be the last question in this part of the quiz. So we're done there. We're on to the second bit. So at this point, you should submit your Google form. In this section, I'm just going to increase the time to 2 minutes. This section is a treasure hunt section. So there will be, the question itself is a clue, and you're open to use Google to try to answer this clue. They revolve around the people you see in the lab and are familiar to all of us. So 2 minutes per question. You're free to use Google to try to find the answer to this question. And any questions regarding citations is based off of Google Scholar for the relevant academics. Okay, I hope that makes sense. Question 1. Our resident photographer, Dr. Li Shen's work was recently published in Science Advances. But what does Li call the thinnest part of the liquid film in his paper? Our resident photographer, Dr. Li Shen's work was recently published in Science Advances. But what does Li call the thinnest part of the liquid film in his paper? Li, congrats on the Science Advances publish. Very impressive. If you do have Li in your group, this is a fairly easy question. But for the others, you're going to have to get Googling to find this one. You only have a minute left. So might have to step on the gas. But what does Li call the thinnest part of the liquid film in his paper? Some very cool pictures in Li's work, usually with bubbles. Had a great Tribo Gathering presentation recently. Very interesting stuff. $40 to go. I hope your internet's fast. Hunting down Lee's Science Advances paper. 30 seconds. Maybe 2 minutes. It's too long. Maybe I cut it down to a minute 45. Make it more of a challenge to those that have to do lit reviews and are very quick with their research. I'm sure you found this already. 15 seconds. 10 seconds to go. 5. And we're on to the next one. Question 2. Janet completed her PhD at the University of Illinois, Urbana-Champaign. What is the title of Janet's PhD thesis? Janet completed her PhD at the University of Illinois. What is the title of Janet's PhD thesis? Looking for just the title of her thesis. Most universities often have a whole catalogue of previous students' theses. Imperial does have their own catalogue, the Spiral Network with old thesis. But does the University of Illinois hold prior students' theses? And if they do, can you find Janet's? And if you do, what is the name of Janet's PhD thesis? A minute to go. 50 seconds, in fact. Just under a minute. Is it related to her current work, perhaps? Is it polymer-based? $20 seconds to go. Hopefully this question is more of a challenge compared to the last one. And we're nearing the end of the time for this question. 5 seconds. Slap it into the Google Doc if you haven't. Sorry, Google Form if you haven't already. All right, time's up. On to the next one. Question number 3. Mark recently tested a range of lubricants on himself with the goal of reducing PPE injuries. In the subsequently published paper, he had to reveal his age. What is the name of Daniele's paper that has the same number of citations as Mark's age? Mark recently tested a range of lubricants on himself with the goal of reducing PPE injuries. In the subsequently published paper, he had to reveal his age. What is the name of Daniele's paper that has the same number of citations as Mark's age? And again, any reference to citations are based on Google Scholar. I was actually supposed to look this up in case more citations were added. In which case, just choose the paper that's closest to Mark's age. But I'm hoping. I think it's a fairly old paper, so I don't know if there will be any more citations as of recent. Let me have a quick look. No, it's exactly Mark's age, the paper we're looking for. Paper published in 2012, and there's 30 seconds to go. This is a hard one. Need to find 2 papers in this. Need to find Mark's paper, find his age, and then head over to Google Scholar and then find Daniele's papers. I don't envy your position. 10 seconds to go. 3 seconds. And we're on to the next one. Question number 4. If you were... Was it question number 4? Yes. Question number 4. If you were a brain surgeon looking to get some extra practice, you'd probably take a look at Zencha's What Does a Brain Feel Like paper. But how much total distilled water do you need to make the brain mimic? If you were a brain surgeon looking to get some extra practice, you'd probably take a look at Zencha's What Does a Brain Feel Like paper. But how much total distilled water do you need to make the brain mimic? Maybe you're a brain surgeon, just get home from work, wanna hone in on those motor skills, want to have a quick look around on how to make something that feels like a brain and acts like a brain, come across a Zencha's paper, and you just need to know how much distilled water though to make this mimic. A lot of other stuff goes into it too, but distilled water is what we're looking for. Total distilled water. This answer obviously doesn't have a range on it because it is just a straight answer. Hopefully the paper is a lot easier to find for this one. So if you put on your brain surgeon hat and sum up some numbers, you'll very soon have an answer for this one. And there's only 15 seconds to go for this one. 5 seconds. And we're on to the last question in this section. Before being promoted to dad, Amir was foremost a tribologist. Congratulations, Amir. In Amir's most cited paper, what is the coefficient of friction of LiMi, which I believe is lithium mineral oil, at 40 degrees Celsius when the MTM was run at 1,000 millimeters per second? In Amir's most cited paper, what is the coefficient of friction of LiMi at 40 degrees Celsius when the MTM was run at 1,000 millimeters per second? So again, a reference to citation. So I would head over to Google Scholar, and just an additional clue for this one. The answer might be on one of the pictures in this particular paper. And again, we're looking for there is no range. We're looking for a particular answer because it's quite clear what it should be. What is the coefficient of friction of LiMi at 40 degrees Celsius when the MTM was run at 1,000 millimeters per second? I'm not going to lie, I didn't read the rest of the paper, so I have no idea what it's about. I'm sure it's a great paper though. Deserves to be Amir's most cited. 10 seconds to go. And this is the last question of this section. So after this one, go ahead and submit this part of the Google form, and it should redirect you to the second bit. And this new section we're going into is the microscope round, so a picture round. There will be pictures of microscope images of objects, and you just need to guess what the objects are. Easy. Question 1. What is this? That's going to be a question for all of these. What is this? What could it be? Quite iridescent. Very repetitive. Layer by layer. I will say a clue. It's biological in nature. If you are stuck, you want to hone in. Biological, found in nature. A lot of biomimetic engineering about this one, trying to mimic some of the properties this has. It's antimicrobial and anti-biofouling surface, so it's got a lot of use in microbiology. People are trying to take advantage of it for urinary catheters to stop infections and other similar things. There is no scale bar, so I'm actually not quite sure how large each individual element is. But that's not the question. The question is, what is this? It's only 20 seconds to go, so I hope you're getting your best guesses in. 15 seconds. 10 seconds. And we're on to the next one. What is this? What could it be? There is a scale bar this time. Again, it is biological in nature, so that's just a clue. If you are guessing fingerprint, it's not a fingerprint. That's another clue. I unfortunately don't have very many fun facts for this one. But I think some people may have ordered a meal involving this creature, this animal, perhaps. Halfway through the time for this question. Question number 2. 3 more to go. What could this be? It's a very nice tone of pink. I think pink was a Pantone color of the year a couple of years ago. Neon green at the moment. Ten seconds to go. What is this object? 1 second, and we're on to the next one. This is such a common tribology one. If you don't get this one, maybe we need to revoke that PhD or kick you off the program. If for whatever reason you're in the lab at the moment, there's a picture of this on in the bioimaging room, I believe. And I think our new PhD student might be working on modeling some of the effects involving this material. Minute to go on the timer. Come on, you guys have got this. Perhaps the easiest one in the microscope round. Also often used to demonstrate how large some of these micron and nano level sizes are. "30 seconds. What is this?" It's referred to in the paper by, I can't remember who it is. A Tribological Day talks about this material. Interesting paper if you haven't read it already. 10 seconds to go. And we're on to the next question. This is a hard one. What is this? Looks super cool though. Again, no scale bar, so I'm not quite sure what the size is, but very cool looking collection of things. A clue here is that it's often found in lecture theatres of the olden days. When I first joined Imperial, back in 2015, our lecture theatre, some of the lecturers still used this thing. There's a whole brand in Japan that's renowned to be the best of whatever this thing is, and a bunch of lecturers have bought it out, and it sells on the black market for ridiculous sums of money. 30 seconds to go. What is this? Looks a bit alien. Is it eggs? Caviar, maybe? 10 seconds to go. And then we'll be on to the last question of this section. On to the next one. What is this? I think quite clearly biological. Lots of strands. No scale bar again, so I'm not quite sure on the size, but we all have some of these, I think. And some of us really want to break these down to then hopefully build them back up again. But what is this? "30 seconds to go for this one. Last question of this microscope section. And then we'll be into the, I think, final section of the quiz. So well ahead of time, I think. If I remember correctly. Oh no, there's 2 more sections actually. So 2 more sections after this one. 10 seconds to go for this one. Biological in all of us. Some of us want to break these down. 5 seconds to go. And we're done. So on to the next section. Just give you 10 seconds to go ahead and submit your new Google form. That should redirect you to the next one. And this next section is general knowledge. Tried to make this as internationally inclusive as possible. So let's get right into it. Question 1. The Tribology group recently acquired table tennis balls and bats and balls to let the overworked, ever-exhausted PhD students de-stress. I can attest to that. How many table tennis balls would be required to fill the prep lab if they're 40 mil in diameter? If you watch this video, Zench is very kindly features in it, and I can tell you Zench is 163 centimeters tall. So if we go back to Zench, I mean Zench to the, it's maybe a Zench and 3/4 Zenches from the floor to the ceiling. And then if we're talking units of Zench, you might be able to work out the entire volume of the prep lab. There is a range on this question. I believe it is plus minus 50,000 table tennis balls. Obviously, we took a rather rough guess at what the actual answer is. But hopefully having Zench as our unit of scale, you can get a decent guess. Again, the table tennis balls are 40 mil in diameter. And the question is, how many would it take to fill the prep lab? And again, it probably looks like a Zench and 3/4 Zenches from floor to ceiling. Maybe 3 Zenches wide and 5 or 6 Zenches across. And that's enough time for that one. So put in your best guess. And we're on to the next question. If I was teleported 600 kilometers at 2 p.m. local time from the eastmost city in China, Fuyan, to the westmost city, Kaixi, also known as Kashgar, what would be the change in local time? If I was teleported 6,000 kilometers at 2 p.m. local time from the eastmost city in China, Fuyan, to the westmost city, Kaixi, what would be the change in local time? And we're talking from all the way, I think you can see my mouse, so from all the way up here, all the way to the left over here. It's a long way to go. I mean, it's an enormous distance. I wonder how many time zones it goes across. What would the change in local time be? I had some great China facts and I forgot them all. What would be the change in local time? Change in local time. 10 seconds to go for this question. 5 seconds. And we're on to the next question. If I wanted to build a true to the periodic table helicopter, what elements would I use? If I was savvy enough to build a true to the periodic table helicopter, what elements would I use? And here, there is a slight clue in the way helicopter has been spelt. Those of you who have memorized the periodic table for whatever reason might be able to answer this one really quickly. I did test these questions on my ME1 maths tutorial group, and there's always one who's memorized every single element, and he got this very, very quickly. But if I was savvy enough to put my mechanical engineering skills finally to some use and build a fancy helicopter, it's true to the periodic table, what elements would I use to build it? 30 seconds to go. It's going to be one expensive helicopter, I can tell you that much. Very expensive element is included here. I mean, some are solids and some are gases, so don't exactly know how this would work, but 5 seconds to go. And we're on to the next question. Mark, Daniele, Amir, James, and Tom were eating minced pies, very Christmassy. Mark finished before Daniele, but finished behind Amir. James finished before Tom, but behind Daniele. What was the finishing order? Mark finished before Daniele, but behind Amir. James finished before Tom, but behind Daniele. What was the finishing order? If anything, this is a bonus question. You guys should be able to get this in minutes. Seconds. You should get it in seconds. Uh, 50 seconds to go, in fact. I'm tempted to give you less just because of how easy it is. But who's hungry enough to chow down their mince pie in record time? And who's watching their diet and taking it real slow? It's not a race, but what's the finishing order? I think from first to last is the way we've got this set up for the mark scheme. What is the finishing order? Two seconds. On to the next question. Last question. People who live in Mamung Kukum Purunkunchia Hill, Australia, need a little patience when it comes to learning to spell their hometown's name. But how many letters are in the world's longest place name? People who live in this particular hill in Australia need a little patience when it comes to learning their hometown's name. How many letters are in the world's longest place name? And here we have a plus minus 10 on the answer. I will give you a clue. I will say it's less than 100. And this place name is located in New Zealand. So if anyone's happens to be in New Zealand, wouldn't we all want to be in New Zealand right now? No COVID. They're living their best lives at the moment. Maybe some of them are there right now. If you want to phone a friend in New Zealand, go for it. But would they know how many letters are in the world's longest place name? Imagine typing that one into Google Maps. 10 seconds to go. And we're on to the next one. That was the final question of that section, and we're into the final section of the pub quiz. It's coming to an end. And this last section is based around tribology, so we're all expecting full marks, obviously. We've had to make this section really difficult because you all know your tribology. So let's get straight into it. Question 1. There are a lot of acronyms in tribology from MTM to ZDDP, but what does ZDDP stand for? Do you guys just throw out these acronyms? Do you actually know what it means? ZDDP? Zinc something or the other? There are a lot of acronyms in tribology from MTM, I think that's a mini traction machine, if I'm not mistaken, to ZDDP. But what does ZDDP stand for? And there's a picture of the structure of ZDDP, I think. So maybe that's a clue if you're savvy with your chemistry. I'm not sure if it is a clue or not. But what does ZDDP stand for? If you do happen to have a paper around, you're not allowed to look at it. It's off the top of your head. 30 seconds to go. A lot of you work with this, so hopefully you know what it stands for. I did test Mao last week, and he did quite accurately say what it was. So if you're in Mao's group, you're safe and sound. 10 seconds to go. And we're expecting perfect spelling for this one. Next question. Cartoons have taught us that banana peels make for a slick trip to the floor, but scientists decided to find out just how slippery they could be. Arrange an ascending coefficient of frictions: banana, apple, and tangerine. So arrange banana, apple, and tangerine in ascending coefficient of friction values. I think this paper won the, is it ING or ING Nobel Prize? The Nobel Prize for funny papers. I think it was done by a Japanese group that used, I was looking at the paper, I can't quite remember their methodology behind it, but what are the coefficient frictions? Banana, apple, and tangerine. Is banana truly the slipperiest fruit? Or do one of the others beat it out? Maybe if you're sitting next to a fruit bowl, you could do a quick experiment yourself. Just step on them and see how far you can slide. 10 seconds to go. There's 3 questions left. Next question. A French scientist studied the rheology of Felis catus. But what is Felis catus? Another paper that I'm fairly sure was at least nominated for the ING Nobel. What did they chuck in this rheometer over here to test the viscosity of? What is Felis catus? I hope you can hear this soothing Christmas music I can hear. There's a minute to go on this question. What evil tribologist decided to study the rheology of this poor thing? Felis catus. "30 seconds to go, and then we've got 2 questions left. The hardest questions the world of tribology has seen coming up. 15 seconds for this one. And we're coming to an end. All right, on to the next question. The Jost report cemented tribology as an important subject in overcoming the cost of friction and wear. Approximately what percentage of global energy consumption originates from tribological contacts? The Jost report cemented tribology as an important subject in overcoming the cost of friction and wear. Approximately what percentage of global energy consumption originates from tribological contacts? And here we have a plus minus 5% on the answer you submit. Plus minus 5%. So how much of global energy goes towards friction and wear? Kind of makes you think tribology is actually quite important. What kind of number are we looking for? I guess all of our work is trying to reduce this percentage. That's the goal. 10 seconds left for this one. Throw in a percentage sign. Need a unit on that number. If it's just a number, ooh. And we're on to the last question in the pub quiz. The pitch drop experiment was started in 1927. The ninth drop took 13.4 years to form and fall. Approximately how many times more viscous is pitch than water? The pitch drop experiment was started in 1927. The ninth drop took 13.4 years to form and fall. Approximately how many times more viscous is pitch than water? And we're looking for an answer in the billion times. And we've got a plus minus 25 billion on this answer. So it's quite a big number. Pitch is a combination of cement and tar, I want to say. I think it's the longest running experiment in the world. And again, we're looking for an answer. It's in the billions of billion times water. Clue might be it's under 500 billion. And this is the last question in the quiz. The Christmas quiz is coming to an end with 15 seconds to go. And we'll get to the answers once Yaps very kindly marked all your submissions. And that is it. That is all the time. So we will stop there, and I'm gonna wait for. I'll start going through it actually, because you should have submitted your answers. So if we go all the way to the top, start over here. Santa Claus is originally red because of a Coca-Cola advertising campaign. And a similar thing happened to Rudolph. Rudolph originated from a marketing campaign, but Santa in particular is red because of a Coca-Cola marketing campaign. In Japan, they give up their extraordinary delicious meals for KFC. Surely a downgrade on Christmas Eve, but apparently they love their fried chicken. We're taking KFC and fried chicken as answers for this one. So the Japanese love their KFC on Christmas Eve. Question number 3. All of Santa's reindeers are scientifically female. Male reindeers typically shed their antlers when it comes to winter, but I'm sure you've seen lots of pictures of Santa and his reindeers, and they typically have all their antlers, which suggests they're all scientifically female. So all 9 reindeer are scientifically female. World's smallest snowman, 2.7 microns. An answer between 2.4 to 3 would cinch you Essentially the points for this one. And Donald Duck. Swedes love Donald Duck on Christmas Eve. Arguably the funniest character in the main Disney cast, perhaps. So Donald Duck is the answer to this one. And this was an exciting one. I did like coming up with these treasure hunt questions. Hopefully you were able to get some of them. Lee came up with a very cool term to call the thinnest part of the liquid film in his paper. He calls it the black hole. So the thinnest part of a bubble film is a black hole. Janet's PhD thesis, if you Googled it, oh, maybe I could show you how to find these. That'd be cool. So if you went to Illinois PhD theses, most universities have a log of all their students. Then you just typed in Janet Wong. Janet's thesis right here. Molecular insights on the boundary behavior of liquids. This question on Daniele's paper that has the same number of citations as Mark's age. A quick way to do this is to find Mark's latest publication. It's actually not his latest. I think he had one with Elsa recently. But if you find Mark's publication on the COVID PPE stuff and do a quick Control F for age. Or maybe not age. Maybe age isn't a good one. Participants, here we go. I'm outing Mark at the moment, but 44 years of age, and then we go over to Daniele. Go on to his Google Scholar. And the paper we're looking for. It's 44. Pressure dependence of confined liquid behavior subjected to boundary-driven shear. That's the paper we're looking for. If you're a brain surgeon looking to get some extra practice, probably take a look at Zench's paper. So if we went to Zench, where's this paper we're talking about? What does a brain feel like? And the clue here is I was looking for a specific number. Ooh. And the number is 491 grams. So if we scroll down, we can find the ingredients for making our own brain mimic right here. And the clue here is we're looking for the one for surgical training because you're a surgeon looking to get some extra practice. So you sum up this distilled deionized water and then this one over here. And that sums up to 491 grams. The next question. Question 5. Before being promoted to dad, Amir was foremost a tribologist. Amir's most cited paper. What is the blah, 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 blah of lithium MI? So we go on to Google Scholar, find Amir, 70 citations, go on to this paper. It's a bit of a harder one to find. But we scroll down and we look for this lithium MI at 1,000 millimeters per second, 40 degrees, LIMI, 0.06. That's the answer we're looking for that one. And that's us, how to get them all done. Microscope, butterfly scales, iridescent, quick cool. Fish scales for this one. Hair follicle, standard tribology stuff. Eric, you should have got this one. Chalk, used in old lecture rooms. And muscle tissue, break them down to build them up even stronger. General knowledge. About 950,000 table tennis balls was our guess, using a HPC close packing structure. Maybe we should have used a BCC. I don't know what these words mean anymore. It's been a long time since I've done materials, but 950,000, we're looking for an answer anywhere between 900 to a million. 900,000 to a million. That's the answer for this one. So if anyone wants to pull a very rad April 1st prank, that's how many table tennis balls you need to buy. 0 hours, unified time zone across China. Trick question, you will teleport. And there'll be no change in time, but there will be massive change in where the sun is in the sky. But 0 hour change in local time. They actually have adopted a slightly different time zone, although I believe Beijing is not too happy about that. If I wanted to build this helicopter using all my mechanical engineering skills, I would use helium, lithium, cobalt, platinum, and erbium. Erbium. I think most people would have got the first 1, 2, 3, 4, but then erbium might have caught you out. Question 4. Emir. Emir is the one gunning to down this mince pie. So it goes Emir, Mark, Daniele, James, and then Tom. Emir, Mark, Daniele, James, and then Tom. Taking a sweet time, enjoying that mince pie as one should. 85 letters for this New Zealand place name. So an answer between 75 to 95 would be perfect. And if you're curious what the place name is, it's this. I'm not going to try to pronounce that. That's a ridiculously long name. And I hope they actually have something shorter for it. So going into tribology questions. ZDDP, zinc, dialkyl dithionphosphates. There you go. If you've been using ZDDP and you didn't know what it stood for, shame on you. Banana, apple, tangerine. Banana does come in lowest out of these three, and tangerine comes in highest, with apple being sandwiched between the two. A cat. A tribologist worked out the viscosity of a cat. Interesting stuff. Really gives you an insight into the mind of a tribologist. Maybe some of us should be worried next time we're near the lecturers. The JOS report, 23%. I don't think that number is actually from the JOS report. I think it's from a separate thing. But 23% of global energy consumption originates from tribological contacts, and that's from treating friction and wear, I believe. 20% to overcome friction, 3% for wear maintenance. And then final question, the pitch tar drop experiment. It's 230 billion times more viscous than water. And here we're looking for a plus minus 25 billion. So 205 to 255 billion would get you the point for this one. And those are all the answers. So I'm hoping Yap has done the maths and knows who's won, and he can tell me, and I can let you know. In the meantime, enjoy this soothing Christmas music, which I hope you can hear. Maybe I've turned off desktop audio. Yap. Do you know who won? Yap. Yap, Where are we in the stream? Okay, I think we're finishing up. Yap, who's won? Yap. Maybe I'll just end the stream because it'll be faster to just get it live. Yap, are you alive? Alright, I think I'm going to end the stream and it'll be fast to just do it on Teams on the main stage.